Hey there, and welcome. Today, we're diving into something that can feel, well, a little intimidating: data. But don't worry, we're not going to get lost in endless spreadsheets. Instead, we're going to learn the visual language that turns all those confusing numbers into clear, powerful stories. So let's jump right in.
Think about it. The last time you saw a huge table of numbers, it's just a wall of data, right? A sea of cells and columns that kind of makes your eyes glaze over. But what if you could just glance at it and instantly see the patterns, the trends, the whole story hidden inside?
Well, here's the thing. You totally can. And it's not about being some kind of math whiz either. It's really just about choosing the right tool for the job. Because the right chart can take that mess of data and turn it into a story that's crystal clear and, honestly, pretty compelling.
And that's all a chart really is at its heart. It's a tool, one that's specifically designed to make information easy to digest. So instead of having to read hundreds of rows of data, you can get the main idea in a single glance. It's all about clarity.
Okay, so the best way to really get a handle on charts is to start with the questions they help us answer. Let's kick things off with one of the most common questions you're going to face with pretty much any data set.
This is a classic, right? You've got sales figures for different regions, or maybe survey results from different groups of people, and you just want to know who's on top, how do they all stack up against each other?
For that question, your absolute best friend is the bar chart. Seriously, there's a reason you see this one everywhere. It just works. The concept is so intuitive. A longer bar means a bigger value. Bam! It's an instant visual comparison.
So when do you pull this tool out of the toolbox? Well, think anytime you have distinct, separate categories. You're comparing sales figures between the North, South, East, and West teams. Perfect. Or you're looking at population numbers for different countries. You can even use it for things that aren't numbers, like school grades, A, B, C, or gender, to see how many fall into each bucket. Okay, but what if your question is a little different? What if you don't just want to compare separate groups, but you want to understand the shape of your data as a whole? For example, let's say you have the test scores for 150 students. You're not really trying to compare student A to student B. What you really want to know is, did most students score in the 70s? Were there a ton of high achievers? How spread out were all the results? See, this is a question about distribution. And to answer that, we need a different tool, the histogram. Now, at first glance, it might look like a bar chart, but it works in a totally different way. A histogram takes continuous data, things like scores or age or salary, and it groups it into ranges, or what we call bins. It doesn't just compare, it actually reveals the shape of your data. Is it a perfect bell curve? Is it skewed to one side? That's the story a histogram tells. Now, here's the dead giveaway, the visual cue you absolutely have to know. Notice how the bars are all touching each other? That is not just a style choice. It's actually the most important feature because it tells you the data is continuous. The 70 to 80 range flows right into the 80 to 90 range. No gaps in the data means no gaps in the chart. It's a small detail, but it means everything. So let's put them side by side. This really nails the difference. Your bar chart, that's for totally separate, discrete categories. Think apples, oranges, bananas. The gaps between the bars are there for a reason. They tell you these things are distinct. A histogram, on the other hand, is for a continuous spectrum, like age, that we've just grouped into convenient bins. The bars touch because the data is all connected. All right, so here's your super simple rule of thumb to keep this straight. If you're counting things in separate boxes, like different school grades, use a bar chart. If you're measuring something on a continuous scale, like salary or age, and you want to see how it's all spread out, you're going to want a histogram. So far, so good. We've compared separate groups, and we've seen how data is distributed. But what if we want to play detective? What if we're looking for hidden connections, a relationship between two different things?
This is where the scatter plot comes in and really shines. Imagine you have two different pieces of info for every person in your study, say their height and their weight. A scatter plot just puts one little dot on the graph for each person, where that dot's position shows both their height and their weight at the exact same time. Pretty clever, right?
And what's so cool is, once you plot all those dots, you can literally see the pattern emerge. If the dots trend upwards from left to right, you've got yourself a positive correlation. Just think about it. Generally, as a person's height increases, their weight also tends to increase. High values go with high values.
And what if the dots slope the other way, downwards? Well, that's a negative correlation. For example, you might plot the number of hours someone studies against the number of mistakes they make on a test. The more you study, hopefully, the fewer mistakes you make. High values of one thing are linked to low values of the other. Then, of course, there are times you get a chart that just looks like, well, a mess, a random splatter of dots all over the place with no clear direction. That, my friends, is what no correlation looks like. It means the two things you're measuring, say, shoe size and IQ, have absolutely no relationship to each other. One doesn't predict the other at all.
Okay, so everything we've looked at so far has kind of been a snapshot in time. But data isn't always static, right? Things change, they evolve. And for that, we need to bring in the most important element of all, time.
And when you're talking about time, the line chart is king. It's the master of showing trends. It literally connects the dots to draw the journey of your data over a period of time. It's perfect for tracking things like stock prices, monthly sales, or global temperatures. With just one look, you don't just see growth or decline, you see the pace of that change. A steep line? That's rapid change. A flat line? Stability.
All right, we've just zipped through 4 super powerful tools, but the real magic isn't just knowing what they are, it's knowing when to use them. So let's boil this all down to a simple guide.
And look, the big idea here is so simple, but so important. It all starts with your question. If you want to compare categories, grab a bar chart. Easy. Curious about how your data spread out? That's a histogram. Trying to find a relationship? Scatter plot. And tracking change over time? That's a line chart all day long. This is your go-to guide.
You know, at the end of the day, it all boils down to this one simple truth. There's no single best chart out there. The best chart is the one that most clearly and accurately tells the story you want to tell. It's your question that should always, always be your guide.
So, here's my challenge to you. The next time you're staring at a spreadsheet, don't just see a grid of boring numbers. See a data set with a secret, a story just waiting to be told. Because now you've got the tools. You know the right questions to ask to unlock those secrets and make your data speak. Thanks for tuning in.